Hi, in this video, I'm going to talk about how we can switch from economics to data science. This is a question I often get from students that are doing post-graduation in economics or PhD in economics, and they want to pursue a career in data science. It's often a question in their mind as to how they can move from economics to data science, whether data science is a suitable career for them or not. They would like to know more about that. Obviously, data science is it's a new field. It hasn't been there for a very long time, so people are a bit apprehensive about getting into this sometimes, and it's no exception that students from economics, which is also a somewhat similar discipline to data science, are somewhat confused, and would like to discuss about how you can sort of get into data science if you have a bachelor's or master's degree in economics. All right, so in economics you study a number of subjects, but most importantly you study econometrics, which is a very quantitative subject. It is very similar to machine learning, and I will discuss about the similarities and the dissimilarities between econometrics and machine learning. But those who are not from economics background, they probably may not have heard about econometrics because it's not a very popular, academic area like machine learning or deep learning, but it is very, very similar to machine learning. In fact, it predates machine learning. And then you also study macro and microeconomics, extremely important areas, and these are also very useful subjects for many aspects of data science. So I'll talk about that as well. And then you study statistics. It goes without saying, statistics is very, very important for a career in data science. You need to have a good background of statistical theory, and as part of your economics degree you study quite some statistics. And then you also study mathematics for economists, which consists of topics such as numerical optimization, non-numerical, so such things, right? So nonlinear programming, things like that, which are again very, very important to give you a good ground of the mathematics of different econometrics and machine learning algorithms. And then you also have special papers depending on which area of economics you are specializing in. If you are studying finance, then you probably have experience of learning risk management. If you're more into policy related, you probably have papers like public finance, where you get a good idea of how the government's formulas, policies, and so on related to taxation, related to distribution of public money, and so on. So some of these areas also are very, very important in many data science career, and I'll talk about it where you can actually find uses of such not so well known areas outside of this field of economics, but very well used in the industry, in the real world. Okay, on the other hand, data science has a few important sort of academic disciplines, I would say. Machine learning, uh, also deep learning, and more recently with advancement in the application of neural network. So machine learning is one such discipline, and there are many areas of computer science which are also somewhat linked to machine learning. And then you have programming, right? Whether it's SQL, whether it's having some experience with computer programming, and then having good experience with statistical programming, such as not just programming, but also statistical programs, such as doing data analysis in Python or R or SAS or MATLAB, such programming languages. And then having fairly good good background of in statistics. That's another. Yeah. Now you see this. Compare these two disciplines. Statistics is common to both. And then in economics also you learn quite some statistical programming, whether it's SAS or MATLAB, and even these days you learn R, right? Not long ago, R used to be given. I mean, it used to be part of economics programs, but nowadays in many university you find that. So you also learn statistical programming these days. So difference is about handling data, having some idea of database management systems, and so on. And the other difference is that while econometrics is a certain type of machine learning, but machine learning has a more wider applications. Econometrics is very focused on more social science, policy related problems, whereas machine learning has much wider applications. And I'll talk about the differences. Let's talk about the similarities first. Well, machine learning and econometrics are very similar disciplines. As I said, econometrics actually predates machine learning. Regressions, the regression problems were first used in econometrics and later in machine learning. So the discipline of econometrics actually existed even before the word machine learning was actually used in academia. So you learn a lot of things in econometrics which are also used in machine learning. For example, you learn regression problems, and you also have regression problems in machine learning. You have limited dependent variable modeling, which is basically your classification algorithm in machine learning, whether it's logistic regression, whether it's other kinds of classification algorithms. And then you have time series modeling. Well, time series modeling is very famous in econometrics, but less popular in machine learning. um, but time series also is a very important part of econometrics. Then you also learn non-parametric modeling, which is less popular, say, in econometrics, but more popular in machine learning, such as your decision tree and things like that. But in both disciplines, you require mathematics and statistics, and that's again a common between both the disciplines. So the bottom line here is that econometrics and machine learning, they are very similar. And if you have good ground in econometrics, you have studied econometrics, you are quite then you are quite suitable to start a career in data science, which requires you to have a good knowledge of statistical modeling or machine learning, and you already know a lot of things. Probably you will have to learn more, and we'll talk about what are the things that you actually need to learn more. Okay, so let me then talk about the different axes. Actually, in machine learning there are a few some nuances of machine learning which are not there in econometrics. Okay, one such thing is the cross validation. So cross validation is the technique that is more often used in machine learning, but very perhaps never used in econometrics. At least I've never come across econometricians using cross validation, right? Building a model in training data and then testing this interest data and then repeating it until you get a very good model. That's something econometricians don't do. Another big difference is that in econometrics, you are not just interested in predicting your target variable or dependent variable. You also want to know the relationship between independent variable and dependent variables. So you look into the p-values, you actually try to explain the marginal density. That means if the x goes up by 1%, what's the change in the y value, right? So basically the marginal density or the relative change with respect to the independent variables. Therefore, you also study hypothesis testing, right? Whether the estimate is significant or not, and if it is significant, how does it impact the change in the dependent variable. All that is very less important in machine learning. At least I've never come across machine learning models where people have given so much importance to hypothesis tests, understanding p values and how they, that's much less important in machine learning models. Although it is gaining a bit more popularity these days because of more in recent times, understanding the theory behind machine learning is now getting more attention from theoreticians. So then it's also using then people are starting to use hypothesis test as well in some areas of machine learning. Anyway, the other one is the feature selection, right? Well, feature selection has a lot to do with your historical research or more domain expertise in econometrics, where you do sometimes use some automated techniques, but they're not that popular. What's more popular is your ability to choose yourself, through the past, through the knowledge that you have from the past paper or the past research on the same problems, or the domain, your own domain expertise. Whereas in machine learning, you actually use a lot of automated techniques to select features, right? Sort of using principal component analysis, using stepwise regression, all that is more popular in machine learning than in econometrics. And then feature engineering, right? Using features, combining features to create new features which can predict your target variable well. That's something very popular in machine learning, much less popular in econometrics, where you are giving a lot of importance to uh, the definition of the feature, because when you combine features you probably may not have a good definition of that new feature when you combine two different features to come up with a new one. Whereas that is less important. Understanding, having a definition is less important in machine learning, but way more important in econometrics, and therefore it is less popular there. And then the last one is the distributional assumption. Well, in econometrics, you give a lot of importance to distributional assumptions because you worry about the hypothesis test, right? You worry about the p-value, whether the estimates are significant or not. So it's very important, therefore, to give importance to distributional assumptions, whether the error terms follow normal distribution on in some models where it is an assumption. In some cases, you have assumptions like having uniform variation of the of the distribution of the data, the of the data. And then in some cases, your independent variables should not be correlated with the error types. So there are many such assumptions which should meet in order to be able to explain the model, the econometrics model. These are less important in machine learning and for sure in data science. But remember one thing, if you know these things, you can be a much better data scientist rather than not knowing it. And that's a problem I have seen, at least people coming from computer science background who actually know how to use algorithms, but sometimes do not really understand the underlying assumptions, don't understand, or they actually haven't been taught actually that fine, you can't simply call libraries and build models. You sometimes have to get into the details of the theory behind the models. And this is where econometricians have a much better lead, a better understanding, because econometrics as a subject is pretty theoretical. So you actually give a lot of importance to understanding theory, deriving the equations rather than simply calling built-in libraries to build models. And that's exactly the reason why economic students are very sought after in data science fields in the US, at least I know, also to some extent in India, in Europe, but much they get a lot of opportunities in the US at least. All right, so these are differences. So you must therefore learn a bit about cross validation, about feature engineering, feature selection, these techniques. Okay, and there are some new models, for example, models like random forest or support vector machines. These are not models used in econometrics. These are very different models, different in the way that, the purpose is exactly the same, like classification. You also have classification algorithms in econometrics, just that the way you build these models, the theory behind them is quite different from the standard set econometrics model. So it's very important therefore to have understanding of such models, so you can go for machine learning courses, also online courses. And that course will be very well supplementing to your master's program in econometrics, where uh, you would have got very good uh, overview of econometric models, and together they will be complementing each other. Um, so what are the steps? What are the steps as a student of economics you should take in order to be a data scientist? First of all, learn econometrics very well. Oftentimes what people think is that, oh, econometrics has no use in data science. We should directly learn machine learning. Well, that's a very bad idea in my view. Um, First, ensure that you understand every single details of econometrics in your master's program or your bachelor's degree. Very very useful later on when you will start your career in data science. I'll tell you, you'll also thank yourself because you will, people who have just got some sort of online training without having proper um, proper training on theoretical aspect of it, they probably will struggle sometimes, but you will have a lead there. Then programming, it's a problem with economics students that economists don't really learn programming, and that's a bad thing actually. So you must learn programming, at least multiple programming languages, at least two in my view. But very important to also learn SQL, which is a database programming language, and it's a simple language, so anyone can learn. So good to learn this. And then don't limit to only policy related problems. Economists actually are notorious uh, in certain ways that they only focus on solving policy related problems, giving advices, but never really focus on problems where the end result is a product or a software, right? That's actually changing, right? Because economists always used to work in central banks and governments and NGOs and banks and commercial banks and so on. But more recently, economists are also working in tech companies such as Amazon, Google, and Microsoft and Uber and so on, where economics are actually working to build products, right? Build better products for people. So therefore, as a student also, you should not limit your research or your whatever case studies you are doing, not related to just policy related things, but also more tech related or product related problems. And then make sure that you have some experience with engineering or product related development. You might also try like building developing a software on your own end to end and put it on GitHub or share it, write a blog about it. It helps a lot. And take advanced courses on machine learning and data deep learning. There are many such good courses. You can also watch YouTube videos to learn yourself, and that will be really helpful actually. So these are some of the steps you can take while being a student of economics, and I'm sure, yeah, you will do very well as a data scientist. It's a field which actually has no clear definition as to, because if you work as a data scientist in a company where you have to do image recognition, that's totally different from if you want to work in a data science field where you have to predict fraud, okay, credit card fraud. That's, the field will be very different. So it again depends on where your interest lies and what your skills are and so on. But economists actually will be making very good data scientists in banking, in insurance companies, in tech companies such as Amazon, or any consumer related company where, because your knowledge of microeconomics will be very very useful, whether it's microeconomics, whether it's game theory, all that will be very very useful there. And your knowledge of macroeconomics will be very useful if you want to work in insurance or banking or organizations there as a data scientist. Okay. Just some myths, but please don't pay attention to them. So some people say data science is not a social science. It's not for social science students. It's wrong. There are many top data scientists working in Google, Microsoft, and other tech companies in the world, and not to mention in many top investment banks who are from social science, and many of them are from economics background. And some say machine learning is a way more difficult subject than econometrics, so it's probably not your cup of tea. But that's actually 100% wrong. In my view, I think they're equally easy, equally difficult subjects, and machine learning is definitely not more difficult than econometrics. In fact, some might argue that it's the other way around. Data science is all about building tech products. That's also not true. Data science is not just about image recognition or such things. Sometimes economic students get intimidated watching YouTube videos where the data scientists are talking all about building tech products and writing long programs for image recognition, voice recognition, text, machine translation, all that stuff. That's not always data science. I mean, that's definitely one, but data science is a much broader area, and there are um, many other fields where economics can be very, very, um, uh, with your economics background will be very, very useful. For example, if you want to work as a data science quant in investment banks, you don't have to use deep learning there. You probably will be doing wonderful if you're good at time series forecasting, for example, right? So that's also a type of data science role where you'll be highly paid. You will be uh, yeah, you can make a wonderful career there as well. So don't get intimidated by that. If you have interest, that's wonderful. You can continue learning this more tech related data science stuff. But if you don't have interest also, you have many other things. For example, you can be a data scientist in policy making. For example, you can be a data scientist for an NGO, or you can be a data scientist for a government, such organizations. And you can also be data scientist for in marketing related domains, customer experience domain. Companies like Amazon, Google, Flipkart, all these companies are hiring such people also. And there, it's a lot to do with hypothesis testing, A/B testing, such things, which are not the type of data scientists who actually build more, technical products, which are more software engineering type, but less of statistical type. Okay, and some say it's a career for CS students, only CS students. That's again not true. Initially, it was the perception of people, but you will find like hundreds of people from economics background are working as data scientists in almost all countries in the world. The last point is just this is my opinion actually, but I don't know if you buy this, but this is just my opinion why economics are very suitable. People with economics background are normally uh, actually very suitable for data science job. Not all kinds of data science job, but in many areas, yes, because they have good theoretical background in econometrics, in microeconomics, in mathematical economics, and so on. It's a discipline full of analytical and quantitative rigor. So students from economics background will never be intimidated by mathematics. So that's one good thing. It's a good mix of science and art. And data science, in my view, is just a mix of science and art. It's not just science where you learn some tools and techniques and you apply. It's also art, and economics being, an art subject, but with a lot of scientific rigor. It brings the best of both worlds. So it's good there. And then it's a subject where you learn to learn story to good telling. It gives you good storytelling abilities. So that's also again very important and very useful. Knowledge of finance and economics is a huge plus in many data science career, particularly in investment banks, other commercial banks, insurance companies. So yeah, such areas. There's some famous people from economics who are working as data scientists. One is Susan Athey. She's PhD in economics. She's also a professor in Stanford University. She was a data scientist with Microsoft, working for the search in program, the advertisement program. So yeah, what she's doing is also very much data science with a lot of statistical analysis, game theory, microeconomics. He's a specialist in microeconomics, so using a lot of stuff from there. And then the other one is Halverian. Probably you must have heard about him because he has written a very good book on microeconomics. So Halverian is the chief economist. Well, basically the kind of work he's doing qualify him as a data scientist. He's a data scientist at Google, and he reports to some of the top guys there. He was one of the advisors when Google actually went public some 15 years back. So wonderful person, very good economist and microeconomist, and he's using statistical analysis to for a lot of the decision making in Google. So these are some of the important people who have made the mark in data science field coming from economics background. Let me also tell you one thing, that during the AI revolution in the 50s and 60s, there was one top economist who was also heavily involved and very well respected in the AI field, who was Herbert Simon, Professor Herbert Simon from Cunning Mellon University. He was an economist, a Prize winner economist. He was very involved in the AI initial days of AI revolution, and has contributed a lot to that field. So, conclusion here is that as a student of economics, you can very well start a career in data science, and the steps that I discussed a couple of minutes back, you can take those steps. These are steps I know. Obviously, there are more steps, but these are some basic steps you can take in order to become a data scientist.